तो हेलो एवरीवन एंड वेलकम टू फिजिक्स वाला गाइस। कैसे हैं आप लोग सब? होप कि आप लोग सब बहुत अच्छे से होंगे और आप लोग अपने लेक्चर्स को रिवाइज कर रहे होंगे। सॉरी इन इंग्लिश। हेलो एवरीवन, वेलकम टू फिजिक्स वाला गाइस। होप you all are doing well and you are revising your lectures and you covered all the subject, not only signal system but whatever the free initiatives are going in your that is the YouTube platform, that is Gate Wallah English. Then every lectures you are going to cover. Okay, now we are here to, that is we are in the 8th lecture. Sorry, this is the 7th lecture, I think so, in a comprehensive course on signal system. And in the last class I have just started the impulse function. In today's class we are going to cover the complete impulse function, and then after that we are going to enter into another kind of function which is known as a real exponential. Okay, so now the point is that if you haven't covered till now what the previous lectures, then go and please cover all the previous lectures. Okay, those who are live, please let me know that my voice and that is visibility, everything is clear or not. Let me check from my side also. Hello, hello, hello. I think it is visible, it's audible also. Okay, fine. So let's revise the class that we have covered till now. Here we have started the impulse properties, and what we have covered till now is this one. See here, we have covered the product property of impulse. We have covered the product property of impulse. Property of impulse function. We say that if we have x of t multiplied with delta t plus minus of alpha, then we have x minus plus alpha delta t plus minus of alpha. Hello Vaishnavi. So x of minus plus of alpha delta t plus minus of alpha, where what is delta t? I said that delta t is a function which exists at t is equal to 0, having the height of infinity but width of ideally 0. Okay, having the height of infinity and width of ideally 0, and we say that minus infinity to infinity delta t dt is equal to 1. This is the area property. That is the area in the curve of this function is equal to 1. In the last class itself I have derived. And also I say that delta t is represented by 1 at t is equal to 0. So this 1 is its area, not its value, mind it, not its value, it is the area that is present here. Now this is nothing but my impulse function, and we have also covered area property. What is the area property? Area property, we say that minus infinity to infinity x of t into delta t plus minus of alpha is equal to x minus plus alpha. So for example, hello Ambika. The point is that, see here, the impulse is present at minus plus alpha and area under the shifted impulse function is equal to 1. So that's why this impulse will not come into the picture. This is what the area property of an impulse, and we have covered, we have derived everything in the last class. Now in the today's class, what we are going to cover is first is the approximation property. Approximation property. Property of impulse. First we cover this, and then we are going to start a discrete impulse function. Discrete impulse function. So these are the two topics that we are going to cover in today's class. Okay, now let's start now. See here, I told you that, for example, if we have a function, okay, if we have a function like this, and if I multiplied with an impulse which exists at either 0, either t, or minus t, okay, then see here, if this is x0, if this is x0, this is x0, this is xt, and that is x minus t, then what is the product result of these two functions? I told you in the last class. See here, I will get, surely I will get as, see, I will get a this function, see here, I will get a impulse at 3 different locations. See, one is this function, one is at this function, this location you will say, assume that xt is greater, and one is at this location. This I am calling it to be the x of 0t, this I am calling it to be the x of t, this I am calling it to be x of minus t. These are the things we have covered already. So this is 0, that is t, and that is minus t. Okay. Hello 𝐂𝐤𝐴𝐿 Singh. Point is that, listen carefully, point is that whenever this is x of t and this is multiplied with delta impulse function, 3 impulse function I have taken, one is at minus t, one is at 0, one is at t, then I will get this as a result. Let's write mathematically. So this is how I will write mathematically. I will write this as a xt, okay, multiplied with, I will write this function as delta t plus delta t plus delta t minus t. Okay, these are the 3 impulse function I have. Now both are multiplied and I will get this result. Let me call this as a yt. So how I will write yt is this function. See how I will write yt. Yt is equal to, come on, how I will write? I will write this is as x minus t delta t plus t, x0t plus x0t delta t plus xt delta t minus t. These are the 3 impulse functions that I will get at these 3 locations. These are the 3 impulse functions that I will get at minus t, 0 and t. Now can I generalize this? What I am saying is that instead of taking 3 impulse functions at a time, can't I take a impulse present at every t? Means that at t, 2t, 3t, 4t, 5t like this, or minus t, minus 2t, minus 3t like this. Let's do it. What I am saying is that let's consider this as a function. This is a function, for example, suppose I have this function, okay, and what I'm doing is that I'm multiplying with Ambika beta, that is the batch for English one actually. Okay, ये हिंदी बैच नहीं है. हिंदी बैच में मेरा कुछ दिन के बाद लेक्चर आएगा, तो आप उसमें भी आप देख सकते हो. और मैं बहुत एकदम नॉर्मल सी इंग्लिश बोल रहा हूँ, इसमें कोई वो नहीं है, मतलब कि मैं बहुत ज़्यादा हाई फाई इंग्लिश का प्रयोग वैसे भी नहीं करता, ना ही मुझसे आती, फ्रैंकली स्पीकिंग। मैं जितना ज़रूरत है टेक्निकल इंग्लिश में, क्या इंग्लिश और क्या हिंदी, ठीक है। बट द पॉइंट इज दैट दिस बैच इज प्योरली फॉर that is the English one, okay, English students. So that is the thing, that why I am using English words here, but the words I am using is very normal, okay, you can easily understand. Still, if you have problem, then please beta attend in a Hindi batch, okay, that's it for English students also. We have a separate channels, one for English, one for Hindi. So what I am saying is that this is the impulse here, see. So impulse is present at each and every point. Let's consider, see here, impulse is present here, here, and here, and here. Let's consider here, here, here. And so on. Let us mark this as 0, that is t, that is minus t, sorry, 2t, that is 3t, and so on. It is minus t, minus 2t, minus 3t, minus 4t, and so on. सर आपका हिंदी बैच कब रहता है? बेटा हिंदी बैच अभी मेरा नहीं है, अभी मैंने उस पर कंट्रोल सिस्टम जो है वो कवर किया है, कुछ लेक्चर्स उसमें कंट्रोल के हुए हैं, लगभग 10 से 12 लेक्चर्स, जहां पे मैंने टाइम रिस्पॉन्स तक कवर किया है। मे बी 28 से मैं उसको कंटिन्यू करूंगा, कुछ दिन के बाद हिंदी में बैचेस जो है वो आएंगे, ठीक है। अभी फिलहाल सिग्नल तो इंग्लिश में स्टार्ट हुआ है। ओके, नाउ पॉइंट इज दैट, सी हियर, पॉइंट इज दैट what is the result that I will get when you multiply both this function? What is the result that I will get? Suppose xt, let me plot the x of t. X of t is this one. See, x of t is this one. X of t is general function. What is the result that I will get? See, I will get a function, I will get a result. What? I will get a result. Surely I will get this result. Okay. That is, I will get a sure function, but see here, a impulse which exists at 0, at t, at 2t, at 3t, at 4t, and so on, at minus t, at minus 2t, at minus 3t, at minus 4t, and so on, and so on, like this. And in between the functions are equal to 0, because the in between the function is not defined. In between the function is not defined. This means that this curve, sorry, this curve, okay, will be 0. So I will have this kind of functions. The question is that this, let me call this as a yt. Question is that how you will write this as a mathematically. How will you write mathematically? What is the expression for yt mathematically? That's what the point is. See here. This is xt. This is x of t. So don't you think that I can write this x of this function? This is the train of impulse, see, present at every t. Okay, this is the train of impulse present at each and every t. So can't I write summation n is equal to minus infinitive to infinitive delta t minus of nt, because this is delta t minus t, delta t minus 2t, delta t minus 3t. Similarly, delta t plus t, delta t plus 2t, delta t plus 3t, delta t plus 4t, and so on. So what I'm saying is that this is a train of impulses. This is the impulse train which present at every t. But question is that how will you write yt? See, I can write this yt as this one. See, what this is x0t, this is xt, this is x2t, this is x3t, and so on. This is x minus t, this is x minus 2t, this is x minus 3t, and so on, and so on up to this. This is 0, that is t, that is 2t, that is 3t, that is 4t, and so on. This is minus t, this is minus 2t, this is minus 3t, minus 4t, and so on. My point is that, see here, listen carefully. Since this is discrete function means it is not present for each and every values of t, it is present only for integer values of t at t, 2t, 3t, 4t, 5t, minus t, minus 2t, like this. This is a discrete function. This is a completely discrete function. If you simply divide it by t, then you will get a number 0, 1, 2, 3, 4. Okay? Hello, Pratiksha. Point is that, see here, since this is also a discrete function, that's what discrete function is. And how will you write this discrete function? I will write this as, see, starting from here. Let me write from here to here. So what you will write? You will write dash 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 x of minus 2t delta t plus 2t plus x of minus t delta t plus t plus x of 0t delta t plus x of capital T delta t minus t plus x of 2t delta t minus 2t, and so on. Dash up to this. Very good evening, Jen mode. Point is that, see here, I can say like that, this is what the shifted impulse function looks like. Okay, so how you can write mathematically? I can write this y of t is equal to summation n is equal to minus infinite to infinite x of nt delta t minus of nt, where of course n belongs to integer, where of course this n belongs to integer. So this is one of the most important point that you have to take care of. This is one of the most important point that you have to take care of. See, if I have a impulse train, this what I am calling. I'm calling this as impulse train. What I will say, this is popularly named as impulse train. So if a function is multiplied by an impulse train, then I will get a shifted impulse functions at each and every point t, provided that x of t exists from minus invertive to plus invertive for t. Okay. Now that's the story of shifted impulse function. But what if instead of I'm saying that this function is present for every integer values of t, what I say that if impulse is present for each values of t, if impulse is presented for each values of t, then the story would be same, but the operator would be different. See here, since it is a finite number, therefore I'm using this summation sign. Now my question to you is that, suppose instead of having let's say finite impulses, if I have infinite impulses ranging from minus inverted to plus inverted, assume that impulse is present at each and every point of t, then how will this expression changes? What I'm saying is that, see, think mathematically in this way. Suppose I have a impulse function which is this one. Suppose I have a function which is this one. Let's imagine that this is x of t, and what I'm saying is that your impulse is present at each and every instant of t, here also, okay, here also. Now for understanding I am making a gap, okay, but mind it that, see here, mind it that there is no such gap between these impulses. The ideal gap is 0, okay, here. Let's imagine like this, in this way. Okay. Imagine that it is present at each and every instant of t. And so on. Okay. Now see here, look at that. Look at this one. See, what I'm saying is that if you look closely, then the impulse is present at each and every instant of time t. Now this axis is not nt, this axis is t. And imagine that impulse is present at each and every instant. The gap that that is maintaining here is to make you understand. But the point is that impulse is present at each and every instant of a time. Now, if you rub this, for example, envelope, the peak of this one, and when you join the peak, what you will get? You will get definitely x of t. See, if you are saying that it is present at each and every instant of a time, then if you join this complete envelope, then what you will get? You will get the same function. Question is that, can't I say that I can slice the signal x of t with what? I can slice the signal x of t through the impulse function. Yes or no? I can slice the signal x of t by an impulse function. I can write the function x of t in terms of impulse. Now, can you tell me that what should be the change on this expression then? Since it is present at each and every instant of a t, so what I'm saying is that this is, see, this complete thing is now represented by integration instead of what? Summation. And let's imagine this nt as a tau. What I'm doing is that I'm imagining this nt as a one continuous variable tau. One continuous variable tau. So how will you write this one? How will you write? Don't you think that I can write this as, see, I can write this as integration minus infinitive to infinitive, okay, x of tau delta t minus tau d tau. What I did, I say that, see here, let's consider this one. Let's highlight this impulse function. This impulse function is highlighted. What is the position of this impulse function? The position, let's imagine that this position is tau. Then what is the value of this function? This value would be x of tau. And what is the position of this function? The position of this function is delta t minus tau. Delta t minus of tau. So this is x tau and delta t minus tau. Now if you add all such delta depending on the values of tau, if tau is 0, impulse exit at t is equal to 0. If tau is 1, then impulse exit at t is equal to 1. T is equal to 2, t is equal to 3, t is equal to 4, whatever. What I'm saying is that if you simply add all such impulses which exist from minus infinity, look at this, I have integrating. What is the integration? It is the addition at each and every point, yes or no? So I am adding each and every point from minus infinity plus infinitive. Then what is the result that I will get? I will get surely a function what? A same function back of t. Okay, I can get a same function x of t. This means that, listen carefully, this means that this is expression. What it is saying is a very simple thing, that any function can be, hello Amrita, any function can be represented by a shifted impulse function. And in this approximation, ideally there is no such error, because what I'm assuming is that there is no such gap between two successive impulse function. So if there is this impulse function, it does not overlap with this impulse function. But you cannot approximate by a step function. For example, let's say, what I'm actually saying is that, see here, suppose I have this function, Suppose I have this function in which what I'm doing is that I have a triangle, then a triangle can be approximated, by a impulse like this. See, triangle can be approximated by an impulse like this, and so on. In this way. Okay, so a triangle can be approximated in terms of impulse function. Now if you remove the peak, for example, then if you remove the peak and then if you join all such peak, then you will get a what? A complete triangle function. That's what the meaning of an impulse function representation. But you cannot make a function, you cannot make a certain function by a step function. What I'm saying is that, see here, suppose I decided to write this function in terms of step 1. Sorry. Suppose I decided to write this function as a step function. Now, so I have what I did, I added a step, multiple step at each and every point. See, let's change the color. Okay, so what I did is that, see here, I am trying to write this function, let's call this function as color change. karte hain. I am saying that this is a white one. Imagine that I want to write this white function x of t through these step function which I have a comma b comma c, 3-step function. Question is that if I add all these function, will I get the same function x of t back? See, if I add all these impulses, I will get the x of t back, that I know. But question is that if I add a, b, c step, then will I get the same function x of t white signal back? No, it's not possible. You know why? Because after this one, see here, what is happening is that this b and this a will interact up to infinity. After c, this a, this c, this b, this a will interact up to infinity. After c, this function, all these functions will interact up to infinity. So what I want to say is that very simply is that since the width is infinity, there is a finite interaction between the successive steps. But here, look at this function. See, this is having a 0 width, this is having a 0 width, this is having a 0 width, this is having a 0 width. So what I am doing is that I am slicing at each and every point. I am able to slice, but I am not able to, that is the right, this because of finite width. Hope you understand. So because of finite width of any function, if you want to write any function in terms of any other function, then the width should be ideally 0, and hence impulse is the only candidate I have present here. I can write the function in terms of impulse function. That is, impulse is the only candidate present here which can purposefully do this job. But step is not the function. Step is not the right candidate because step has a finite width and there's an interaction between the widths. You understand my point or not? That is the reason why this is a basic fundamental for a fundamental. This is a fundamental for a linear time invariant system. Fundamental for LTI. So have you ever wondered that why we always want the impulse response? See, in a control system, always we want an impulse response whose Laplace is transfer function. But you never heard that I want a step response you will get from impulse response itself. But what is fundamental? Fundamental is the impulse response of a system. Yes or no? Impulse response you must know. Impulse response is a basic characteristic of mathematical characteristics of a particular function, because you can write any function in terms of impulse, but you cannot write any function in terms of other functions where the error is equal to 0. You can write, of course you can write, but there is a finite error. But this is what the ideal situation is. This is what the ideal situation is. Ideally, yes. Situation. But practically guys, it is not possible that a function exists only for 0 time. Means it is having a width equal to 0. It will have a finite width like this. See, it will have a finite width, and there is a finite error. There is a finite error when you write a function in terms of impulse. Also, there is a finite error. But mind it that compared to all other signals, the error is ideally minimum. You cannot say that I will get a maximum error when you compare with any other signals like this. See? So there is a finite width, there is a finite gap. This is the gap. See, this is the gap that you are having. This much of a rectangle function. See? I told you when I derived the impulse function that what is the impulse function actually? What is the impulse function actually? Impulse function is a rect function whose width ideally becomes a 0 and height becomes an infinite. So what I am saying is that, see, ideally the width is very small, not equal to 0. So you will have a rect sampling. So that is the reason why you have a sampling of two kinds. One is an instantaneous sampling, or you will say a natural sampling, and one is an ideal sampling. Ideal sampling is this one. See, this is what my ideal sampling is, but this is what my natural practical sample is, which you get from PCM, pulse code modulation. Is it clear? A rect function is there. So sample and hold circuit, sample it and then hold it for few time, because I need a finite width, and for that we have a pulse stretcher circuit which are present in communication. So that is what the practical example why we use the impulse function here. Every time why we always demand an impulse function. We never want a function in terms of a step function, though you can write, but there is a finite error. Hope you understand the point that why impulse function is needed. Okay, so this is what the approximation, this property we call it to be, this property we call it to be the approximation of function in terms of impulse function. So any function can be written in terms of impulse function, and the error ideally is 0, because there is a 0 width ideally present here. Okay, now, so that's what a complete CTS impulse is, and that's over now. After that, let's consider a discrete impulse function. This is one of the most important point, most important topic that we are going to cover in our class. Okay, discrete impulse function. To have a discrete impulse function, let's consider a interesting signal. Plot xn, which is un minus un minus 1. un minus un minus 1. What is the un? un is a function which exists for like this: 0, 1, 2, 3, 4, 5, and so on. This is what my un is. It is just a discrete version of ut. It is just the discrete version of ut, okay? But what is un minus 1? See, un minus 1 is a function which is not present at 0, which is shifted by 1. So 1, 2, 3, 4, 5, 6, and so on. Now what I am doing is that I am subtracting both these functions. When you subtract both this function, then what you will get is that, so this is cancelled by this, 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 and so on. But you left with this signal, don't you think? You left with this signal. Okay. So I have a function which exists at 0, at n is equal to 0, and is 0 else. Everywhere it is 0. See, 1, 2, 3, it is minus 1, minus 2, minus 3. Everywhere it is 0. It only exists at n is equal to 0. This function we call popularly as delta n. So delta n is 1. Delta n is 1 for n is equal to 0 and is 0 else. 0 else. And what is the sequence representation of this xn? The sequence representation is 0, 0, 0, 1, 0, 0, 0, and here is the arrow. This is what my sequence representation of this xn. So what I am saying is that this is a discrete xn which is present. Also, if you add all the sample value, listen carefully, if you add all the sample value, if you add 0 plus 0 plus 0, this value is 1, this value is 1, 0 plus 0 plus 0 plus 1 plus 0 plus 0 plus 0, then surely you will get 1. Means what I am saying is that summation n is equal to minus infinitive to infinitive delta n, which is equal to 1. Summation n is equal to minus infinitive to infinitive, that if you add all the sample value of this function, then it is equal to 1. What I am saying is that, see, so what I have covered till now is, listen carefully. See, what I am saying is, I have a delta n which is 1 at n is equal to 0 and is 0 else. It exists at this point. N is equal to 0. Unit sample signal, you will say. This is 1, this is 2, this is minus 1, this is minus 2. This I am calling it to be xn as 0, 0, 0, 1, 1, 0, 0, 0. Here is the arrow. And this I am saying that summation n is equal to minus infinitive to infinitive delta n is equal to 1. This I am calling it to be a unit sample function. This I am calling it to be a unit sample function. Simple. Throughout, this is what the impulse function is. Now let's compare this thing with a what? Continuous impulse function. What we have covered in the last class. So delta t is 1 at t is equal to 0 and is 0 else. How you will represent? You will represent by a arrowhead at t is equal to 0. And minus infinitive to infinitive delta t dt is equal to 1. But mind it that this 1, okay, this 1 is its area under the curve. Area under curve. You remember? But this 1 is its value. This one is value. So this is what the value function is. This is what the area function is. This is a difference between a continuous impulse function and discrete impulse function. So there is a finite difference between continuous impulse function and discrete impulse function. Okay, fine. One more thing that I have covered, that d by dt of ut, if you go for the last class, then d by dt of ut is what my delta t is. D by dt of ut is delta t. But just now only we have covered that delta n, okay, delta n is un minus un minus 1. See, this is what un minus 1 is what my delta n is. This is delta n. This is what my delta n is. This means that, see, look at the difference here. The differentiation in continuous one, the differentiation in continuous function is what? A difference equation in discrete function. The differentiation in continuous function is a difference equation in discrete function. This is one of the most important point that you have to take care of. See, what I'm saying is that if suppose for example I am saying that I have my yt is equal to d by dt of x of t, okay, then suppose someone asks you that let's discretize this. Let's discretize means if you, let's say, sample this function x of t, then what should be the relationship? Then I can say that yn is equal to xn minus 1. This is, we say that this is the first differential equation. Okay, equation, and this I am saying that it is first difference equation. First difference equation. That's what the point is. So this is the first differential equation, and this is what the first difference equation of a system is. Okay. Similarly, we have a second differential equation. Means I have a yt which is equal to d2y by dt2, and hence prove that my yn is equal to, that is, xn minus, okay, you can find out. How you will find out? See here, d by dt of x of t, xn minus 2, x of n minus 2 minus x of n minus 1. Check it please. Check the coefficient please. I am giving you homework that derive this function, though easily you can derive it. See, d by dt of x of t, d by dt of x of t. Now you have to consider this as a 1, equation number 1. You can write this as yt equal to d by dt of x of t. d by dt of x of t. Now this is equal to, let's consider this as what? Let's consider this as some function pt, some function pt. Let's assume this function to be a zt, whatever. Then this yt can be d by dt of zt, yes or no? So this yn can be Zn minus Zn minus 1. In will be Zn minus Zn minus 1. But what is Zt? Zt is d by dt of xt. Okay. This means that, see here, d by dt of x of t. This means that Zn is xn minus 1. But I want Zn minus 1 also. if you want to write in terms of yn, then I want Zn minus 1. Zn is this. What is Zn minus 1? Zn minus 1 is simply put n minus 1 minus x of n minus 2 shifted by minus 1. That's what the meaning is. Now replace this Zn, you know, Zn minus 1, you know, substitute here. What you will get? You will get yn is equal to xn minus x of n minus 1 minus x of n minus 1 minus x of n minus 2. Okay, so this will be equal to yn is equal to xn minus 2x of n minus 1 plus x of n minus 2. That's what the second difference equation is. So d2y by dt2, the difference equation is this one, and so on, and it will go on like this. So in general, see here, in general, if you have yt equal to dnxt by dtn, then yn can be represented as summation k is equal to 0 to m bk x of n minus k. This is what the kth differential equation, and this is what my, let's say, another differential equation. Imagine it to be a, this is a, so let's call it to be m. So that same power should be there. For example, if you put n is equal to 1, m is equal to 1, then what you will get? Yt is equal to d by dt of x of t, which can be written as yn is equal to, see, 0 to 1 means b0 xn plus b1 x of n minus 1. That's what the meaning. Similarly, if I put m is equal to 2, then yt is equal to d2 of xt over dt2. And how you will write? You will write bn as equal to what? b0 xn plus b1 x of n minus 1 plus b2 x of n minus 2. This one. Now what are the values of b0, b1, b2? We already find out. See here, b0 is 1, b1 is minus 1. Let's write b0 here. Let me change the color. b0 is 1 and b1 is minus 1. So d by dt of x of t, discrete form is xn minus 1. That's what the meaning. Similarly here, what is b0? b0, easily you can find out. Look, b0 is 1, b1 is minus 2 and b2 again is 1. So b0 is 1, b1 is minus 2, b2 is 1. There is no such hard and fast rule to find out the coefficient b0, b1, b2, bk. We cannot find, means there is no such rule to find out. You have to go by iteration in the same way. I have derived till 2. I am giving you the homework for third order. I am giving you the homework for third order. Easily you can find out the third order. A third order differential equation. This is what? This is what? This we call it to be the mth differential equation. And this is what? Mth difference equation. So what I have covered till now is that the differential equation, okay, the differential equation in time domain is converted into difference equation in frequency domain. Differential equation in time domain is converted into difference equation in frequency domain. This is one of the most important thing, and this is the mth order FIR equation, finite impulse response equation, that we will cover when we entered into the digital filters. Okay, that we will see. But I have covered this one. I am giving you the homework. Find yt d3, find yn, d3 yt, d3 xt over dt3. Then we have to find out the yn. Same, exactly same method you have to follow. Iteration by iteration by iteration by iteration, easily you can find out. In general, what coefficient you will get? You will get the coefficient b0, b1, b2, b3. You have to find out this coefficient and write this in terms of this one. This is the homework for you. So second thing, first thing is this one. Second thing, what you have considered. So I have derived from this one. See, look at that. And one more thing. See, the integral equation. This is the integration is converted into summation. Look at this. Whenever you talk about the discrete function, the integration will convert it into summation. The differential equation will convert it into what? Difference equation. That's what the point that you have to take care. That's one of the most important point, which is nothing but my there. Okay, now having said this, let's talk about now application of impulse function. Same thing is there. Same thing is there. Application of impulse function. Of impulse function. Now what I am doing is, suppose I have a function xn. Let's consider this one. Let's consider this as a value 3. This is -4. This is 5. This is 4. And that is 6. This is what my xn is. And let's imagine that I am multiplying with one impulse function at 0, another impulse function at 1, another impulse function at 2, another impulse function at -1, and another impulse function at -2. So this is 0, this is 1, this is 2, this is -1, and that is -2. Somewhere here is a 0, somewhere here is a 0, somewhere here is a 0. What I am doing is that I am multiplying with each and every function. Let's call this as mathematically how you will write. See, first let's consider this one. This is 0 point, this is 1, this is 2, this is -1, this is -2. And let us consider this as a delta n. This is delta n -1. This is delta n -2. That is delta n plus 1. This is delta n plus 2. And so on. Now when you multiply this function xn by delta n, what you will get? See here. I will get xn I have, and I am multiplying with delta n. What is the result that I will get? The first result that I will get is 5 times delta, because This is a number having 1. Everything is 1 here, okay? Everything is 1 here. This 5 multiplied by 1, you will get a 5. But what you will get? You will get the first result is this one. See, let me write the first result first. First result is this one having a 5. What you will at 1? This is 5 delta n, which is actually x0 delta n. What is 5? See, look at 5. 5 is x0. x0 is 5. At 1, what is the value here? 1. At 1, what is the value here? 4. This means that this result I will get A. What is the B result that I will get? The B result, this is at 0, sorry. At 1, I will get 4. See, look. This is 4 at 1. This is 1 at 1. So 4 into 1 is 4. So what you will write? You will write this as 4 delta n minus 1. Four delta n minus 1. But what is 4? 4 is x1 delta n minus 1. See na? 4 is what? x1 delta n minus 1. Similarly, the second would be at 2, and what should be the result? 6. This value should be 6. Not to be scaled. So this should be what? 6 delta n minus 2, and this is x2 delta. Similarly, what about this one, minus 1? So at minus 1, we have a value minus 4. And what you will write? You will write minus 4 delta n plus 1, or minus 4 delta, sorry, it is x minus 1 delta n plus 1, and so on. This means that, see here, this means that if this is xn multiplied by delta n minus 1 delta n minus 2, the same value you will get here. So what I am saying is, let's generalize it. I am saying that I have xn and multiplied by delta n. The result would be x0 times delta n, because impulse is present at n is equal to 0. On the other hand, if I have xn and multiplied with delta n minus alpha, where alpha of course belongs to integer, otherwise the impulse will not exist. This would be, see where the impulse is at alpha, this is x alpha. Look at this second example, where the impulse was minus 1, so therefore impulse was at 1, so you will get x1. Similarly, x alpha delta n minus alpha, and similarly we have xn into delta n plus alpha. Alpha belongs to integer, is x minus alpha delta n plus x minus alpha delta n plus alpha. So this is what the impulse here, we call this as this I am calling it to be a product property. Product property. Exactly the same thing we have covered in the continuous time also. The same thing we are covering in discrete time also. Exactly same thing. Now the point is that, listen carefully. Acha, suppose if I add all these values, suppose this is -1, this is this is 1, this is 2, this is -2, this is -3, and so on. If I add all these values, what you will get? 5. Na? If you add all this value, what you will get? 5. If you add all this value, what you will get? All the samples are 0. If nothing is noted, this means that they all are 0. If you add all the values, then you will get 4. Similarly here also, if you add all the values, you will get 6. If you add all the values, what you will get? -4. But what is 5 here? 5 is x0. So what is 4? 4 is x1. What is 6? 6 is x2. What is -4? -4 is x -1. What I want to say is that, listen carefully. Suppose I have xn multiplied with delta n, and I am adding from n is equal to minus infinitive to plus infinitive. I am adding n is equal to minus infinitive to plus infinitive. What you will get? See, because of that, I know that this is equal to summation n is equal to minus infinitive to infinitive x0 into delta n. Yes or no? x0 is a summation which is a number. X0 is a number. So it is outside. What you will get? You will get x0 summation n is equal to minus infinitive to infinitive delta n. But what is this? See, what is this? This is equal to 1. The sum of all the sample values of delta n is equal to 1. This means that this is equal to x0. This is known as sum property. This is known as sum property of an impulse. This is known as sum property of impulse. Similarly, suppose I have summation n is equal to minus infinitive to infinitive xn, and I have delta n minus alpha. N minus alpha. Alpha of course belongs to integer. Then this is equal to, see where the impulse is at alpha. This means that summation n is equal to minus infinitive to infinitive x of alpha delta n minus alpha, and again x alpha is outside the summation, so this means that it is equal to x alpha summation n is equal to minus infinitive to infinitive delta n minus alpha. This is again equal to 1, and hence this value is equal to x alpha. Same, you can write it as summation n is equal to minus infinitive to infinitive xn delta n plus alpha is x minus alpha. It is exactly the same property, area property we have covered in the continuous time. Exactly the same property it is. What was the area property? See, area property was minus infinitive to infinitive xt delta t plus alpha dt is x minus alpha. Same property it is. The only change is that integration is replaced by summation. The only change is integration is replaced by summation. Now, so this is what the summation property is. Exactly in the same manner, suppose I have, see, suppose I want to write this xn. How can we write this xn? This xn can be written as, see, it is 5 delta n plus 4 delta n minus 1 plus 6 delta n minus 2 plus, actually minus 4 delta n plus 1 plus 3 delta n plus 2. You can write this as a xn. But what is this 5, 4, 6, minus 4, 3? This is x0. This is x1. This is x2. This is x minus 1. This is x minus 2. This means that the xn can be written as x minus 2 delta n plus 2, x minus 1 delta n plus 1, x0 delta n plus x1 delta n minus 1 plus x2 delta n minus 2. That's what the meaning. But since this function was from minus 2 to 2, minus 2 to 2, that's why we have from x minus 2 to x2. Imagine that if this function was from minus infinity to plus infinity, imagine that if this function was from minus infinity to plus infinity, don't you think that I can write the same function, okay? I can write the same function as what? It is xn is equal to summation k is equal to minus infinity to infinity xk delta n minus xk delta n minus of k. Exactly, see, k value is minus 2, k value is minus 1, k value is 0, k value is 1, k value is 2. This is the defined function. And see here, this is same as xt is equal to minus infinity to infinity, that is x tau delta t minus tau theta. So any function can be written either in CDS, this is in CDS, but this should be in DTS. Any function can be written in terms of shifted impulse function either in CTS, either in DTS. The meaning is exactly same. So that is what the meaning, that any function can be represented by impulse response. For example, suppose I have suppose I have this function, zero, 1, 2, 3, 4, 5, 6 up to so on. This is un. How will you write un? Un can be written as delta n plus delta n minus 1 plus delta n minus 2 plus delta n minus 3, so on and so forth. Or you can write this un as summation k is equal to 0 to infinity delta n minus. Very simple. So this un can be represented in terms of impulse function. Similarly, any function can be represented. Had it be 1, 1 can be what? 1 means what? Everywhere 1. From minus infinity to plus infinity, what should be the change? The limit would be from minus infinity to plus infinity. That's it. 1 would be k is equal to minus infinity to infinity delta n minus of k. That's it. Now compare this equation with this equation. See, what is the xk here? Xk is 1. Xk is 1. Here also Xk is 1. And here also Xk is 1. And indeed they all are value. They all are value. So value is equal to 1. So value is equal to 1. So that's what the meaning of nothing but my representation of impulse function. So these two classes was one of the most important class, guys. And mind it that in both the classes I have told you that what is the physical representation and what is the meaning and what is the value of nothing but my representation of an impulse function. What is the meaning of an impulse function? So what we have covered now till we have covered the impulse function, for both TTS plus DTS, TTS plus DTS, and properties of impulse function, in which in CTS we have covered area, product, here also product, area, here sum, here approximation, here also approximation. Okay, so this is the properties of an impulse function that we have covered till now. If you have understand this, then it will be pleasure for me. Those who have any doubt, do ask the doubt. Okay, from the next class onward, impulse function is covered, step function is covered. We will cover exponential in the next class, and then both complex exponential, real exponential. Then we talk about the properties of a signal, where we will talk about the periodicity, energy and power, and then we will talk about what symmetry on signals, even signals, odd signals and all. Okay, with this, thank you very much, guys. Thank you. Hope ki today's lecture you understand, and please do revise all the playlist if you want a serious, that is a preparation for GATE, and if you want to excel on signal and system. If you have doubt, I am here to ask the doubt. Please do message me in the comment box also. You can put your doubt, and any suggestion is there, please let me know. Is it clear? Tomorrow onwards we will start some problems also. So with this, thank you very much. Thank you.